In this video, we will talk about the intro to Chapter 1, Section 4, which is really what we did in class after the first day of this lesson here. So I'm going to assume then that the lesson has been, that we have passed through the lesson already, so I'm not going to explain things in as great a detail as we do in the lesson. So we want to solve the following equations. We have absolute value of x plus 3 equals 13. Now, we know that an isolated absolute value equal to a positive number could have two answers, and so we set up two equations, and those equations would be x plus 3 is equal to 13. The second equation, x plus 3 is equal to negative 13. We're going to subtract 3 on both sides, and we end up with x is equal to 10. Subtract 3 on both sides, and we have x is equal to negative 16. Now we know from what we've done in the lesson that this question is asking what number or numbers are 13 units away from negative 3 on the number line. When you see the positive, the plus 3, it really means x minus negative 3. So if I were to graph these, to just check my work, I have negative 16 and I have positive 10. And if I wanted to find the average, I add negative 16 plus 10, gives me negative 6 divided by 2 is negative 3. And the distance we know will be 13. And so we've double checked. The distance, the numbers negative 16 and positive 10 have a distance of 13, or are a distance of 13 units away from negative 3 on the number line. We'll go on to the next. Scroll down for the next one. So in this case, we have the slightly more complicated version. We don't have an isolated absolute value of x, and then inside the absolute values we have 3 times x minus 1 and not just an x minus 1. So our first job is to isolate the absolute value. We're going to do that by subtracting 6 on both sides. And when we do that, we end up with absolute value of 3x minus 1 is equal to negative 2. And right away we should note that an isolated absolute value of x cannot be negative. Now I said an isolated absolute value of x, but in fact an isolated absolute value period cannot be negative, and so in this case there are no solutions. We'll go on to the third part of this. Okay, in problem number 3, we're told to drive safely along a road. Drivers need to maintain a speed of at least 50 miles per hour and at most 60 miles per hour. Write an absolute value equation that represents the minimum and maximum speeds. Well, we know how to do this. We set up a number line with our minimum speed of 50, maximum speed of 60. The average of those two, 50 plus 60, is 110. Divided by 2 is 55. But we could probably tell that 55 is halfway between 50 and 60, and that the distance from the center is going to be 5 units. And so we end up with an equation that is absolute value x minus the center equals the distance from the center, and that does it for these 3 problems in the introduction.